Welcome to clickmyproject.com. The title of this paper is Mutual Information Based Supervised Attribute Clustering for Microarray Sample Classification. This project comes under the domain data mining, and this mainly deals with the concept of feature selection because most probably biological experiments deals with the high dimensional data. High dimensional data in the sense it will consist of number of columns and numerous rows. To reduce the number of columns, to reduce its time complexity, feature selection concept is applied in this biological field. To conduct any biological test like disease prediction, classification, etc., the first thing is to be needed is to apply feature selection, because among the group of features only some particular amount of feature is more effective than others, because high dimensional data will contain large number of feature sets. Among those feature sets only some amount of features will be effective to predict those diseases. So our work is to predict such features from the large amount of data. For predicting such features, many approaches have been proposed. There exist two types of existing works. One is supervised and another one is unsupervised. What is supervised? Supervised in the sense it will be depending upon the class labels and it will be predicting the features according to the class labels. And another one method is the unsupervised method. Unsupervised method in the sense it will not depend upon any class labels. It will consider the entire data and it will perform calculations according to that, and the features will be selected regarding that. The disadvantage regarding unsupervised method is that it will contain many redundant attributes that will not be more effective. To remove such ineffective attributes, we propose a new method called Mutual Information Based Supervised Clustering Algorithm. This algorithm uses the supervised technique. Many existing works also used supervised technique. The only drawback in those existing systems is that they did not depend upon that mutual information. Mutual information in the sense it will find the similarity between attributes. This similarity value will be computed between the attributes. This will remove the redundant attributes from the feature set. To improve the efficiency of the subset which is selected, we use this mutual information based supervised clustering algorithm. Now I will explain the proposed clustering algorithm. The initial step of this proposed supervised clustering algorithm is to find the supervised similarity measure between the attributes. Let us assume that number of samples have been taken. For example, number of samples in the sense number of data sets will be taken. And the A1, AI, AM represents the attributes in that particular sample, and D1, D2, etc. Dn denotes the class labels present in that attribute set. In order to predict the relevance between attribute and the class label, we need to find the mutual information between that attribute and the class label. If we want to find the mutual information, that is information of AI with respect to the class label D, we have to find this H of AI and H of AI over D. In the sense, in this regulates the entropy value, and this identifies the conditional entropy value. Entropy in the sense it will identify a unique value for each attribute, and conditional attribute defines the value for a particular attribute according to some particular class label. To find such values, we have an equation which is specified with the integration operation. P of y represents the probability density function, and P of y comma z represents the conditional probability density function. With this value, we will substitute this entire thing in this. This is the entire supervised similarity finding algorithm equation, in which S of ai comma aj represents the unsupervised similarity between the attributes. Our proposed algorithm also considers the unsupervised technique in order to avoid some limitations. We will calculate H of AI over AI aj over D, and we will calculate the entire supervised similarity between the attributes. The similarity value will be existing between 0 to 1. If it is 0, then the attributes are not correlated to each other. If it is 1, means they are most correlated with each other. Hence, our supervised technique will be implemented as further. With this similarity value, we will form the coarse cluster. Coarse cluster is nothing but the initial cluster. Our process will be processed with number of iterative clusters. Initially, one cluster will be formed, and after that, multiple iterative clusters will be formed. Finally, it will be reduced to one finer cluster. The attributes within that finer cluster will be considered as the effective attribute. Now I will explain the flow of this project. Initially the gene data set is loaded and the initial attributes present in this is selected. Between the attributes the relevance value is computed, and then for that relevance value entropy and conditional entropy values are computed. With that the supervised similarity measure will be computed. With that supervised similarity measure the representative will be selected, which is considered as the highest value, and the initial cluster will be formed with that. Likewise iterative clusters will be formed, and finally we will obtain a finer cluster. The finer cluster will be obtained by using the merge and average representatives. That is, we will collect all those representatives which are selected as the head for each iterative cluster. Finally the attributes within the finer cluster will be considered as the effective attributes, and the result will be displayed here. Now I am going to show the demo of this project. For this we need NetBeans and WAMP server. WAMP server is the backend. After starting the WAMP server, click on this home.java and right click run file, select run file. After this we have to load the dataset. It is present in e dataset.csv. After this we have to convert that into the ARFF format. The ARFF format is shown here. We have to extract this data and store it in the database. The extraction process will compute this values alone and it will be stored in database. This is the data stored in database, and sample 1 represents the class label 4 and sample 2 represents the class label 2. After this initial attributes which are in that dataset will be displayed here. For this we will find the standard deviation of each attributes. After this we have to compute entropy, conditional entropy, and with that values we will compute the relevance value. Proceeding with that, unsupervised similarity will be computed. For that also we will compute conditional entropy, and the unsupervised similarity will be found out. After that supervised similarity will be computed. The equation will be solved and the entire similarity between two different attributes will be shown here. After this representative have to be chosen. The representative for two different class labels is selected and the course cluster is formed with that. This attributes forms the initial cluster. After this augment cluster values will be computed. Augmented cluster in the sense iterative clusters will be formed. For that we will compute some values and the iterative clusters will be formed. Finally at one stage there are no more attributes will be there to choose as a representative. It will display here, no more representative can be chosen. Finally we will choose the attributes which are selected as the representatives. That forms the finer cluster. It is shown here. Our project ends with this. Thanks for listening the video.